then obviously that this is 2 digits, the partial square, u partial x squared plus partial u partial square u partial y squared is 0. And u is xy, right? And then so you have basically 1 over x, e squared x, the x squared, 1 over y, e squared y, the y squared, 0. So both terms should be a constant. Now you look at the boundary conditions. So because x in the x boundary you have both sides set to 0, so you're pretty sure that you need the oscillatory function, so that becomes a negative term, whatever that is, negative alpha square. I don't know whether alpha is a good way, but that doesn't matter. Then this becomes alpha square, right? So obviously x is a sine alpha x plus b alpha x. Then y would be, well, you can use cos sinh. Later on, because of this boundary condition, most likely you use sinh is better. Right, so that's the general form. So now you write it down as a combination. And to satisfy the boundary condition at x is 0 and L, pretty sure we did that before. So that should have a coefficient and sine. Forget about this alpha. So you just use your own variable. Just make sure this is the same as that one. That would make it the same form as this one. So like n pi x over L. N will be 1 to infinity, right? So that fix this x. So basically just choose the sine term, not the cosine term. And the y solution, you want the sinh one because that will satisfy the lower boundary sinh. Now you make sure that this alpha is the same as this alpha, so n pi y over L. The a will be depends on n. Right, so that's the general form, right? You got this, something like that? Yeah, yeah, you need a pi. You need a pi, so because you sine n pi, right? At x equals to L, you need sine n pi to make sure that this is 0, right? Anyway, the boundary condition to solve for a, you need a boundary condition that would be t2 minus t1 over t1 equals to 1 to infinity, and 3 sub n sinh n pi, because you choose y equals L, right? And that is your coefficient of a Fourier series. Right? The rest is to solve for the coefficient for the Fourier series. You can either look up the formula or try to figure it out, because when you multiply the same factor on this side, integrate over the whole length, right? And then all the term without n not equals to m, because when you do it, you multiply by another factor, you use another variable instead of n pi x, you get m pi x. M is not equals to n, or the integration will be 0. The only term survive is n equals to n. Basically, you multiply n squared. And when you n squared integrate over the length of the box, then that's basically get your average. which is 1/2 for sinusoidal function. So the integration will be L/2, right? And so basically that you need to divide it by L/2. So basically that implied the coefficient is NC n pi equals to, we divide it by L/2 to 2 over L, integrate 0 to L. That is just a constant basically for our problem. So that is actually going out of the integral. Then sine n pi over L. Right. Then you just do the integral. There's 2 over L, d2 minus d1 over d1. That's cosine. It's actually negative cosine. And then divided by L, divided by n pi over L over n pi. Yeah. Obviously, n is not 0 because we are summing n from 1. So that's fine. And now this is evaluated at 0 to L. Right? Do you get something like that? Right. So now you just substitute. So cosine 0 is 1. And then x equals L, you get cosine n pi. What is cosine n pi? So sum at 0. Cosine pi is minus 1, right? Cosine pi is minus 1. Cosine 2 pi will be 1. Is it true? Yeah. No CO10? Right. So n pi, the cosine. You need a cosine n pi. N pi is minus 1 to the n. Is it? Cosine 2 pi is 1. Cosine 0 is 1. We don't have 0, but all the even 1, even terms are 1. So this is 0. But you subtract by 1. 1 minus 1. Yeah. So because your subtraction, you only keep because even term will cancel. Only odd term will give you a factor of 2, right? Because that n is odd, then it's minus 1. There's so minus 1 plus 1, minus 1, the lower limit, right? So, but anyway, you know what I'm saying. You get something like that. Your question is you didn't get to this part or what? Okay, so you get to something like that. That's Fourier. You got the Fourier expansion, right? Fourier series. After you Fourier series, this is just to solve the coefficient of the Fourier series. And this is a function, but although it's a constant, but it's still a function, right? And that makes the integral easier, but still just the Fourier series formula. Is that okay? So that would be this part. So you are getting stuck at this, so you don't know other part, whether you have problem with other part, right? The other part is sketch the solution. It should be easy. Yeah, the other part is just discussion, so that should be easy. Okay. Any more? Is it clear enough for this question? Okay. No. Yeah.
Losing track of
the
left side of the dotted line and
this
the right side.
This one to this one.
No clue.
This is the you are not in the last semester. We went through the Fourier series chapter. This is Fourier series. So the Fourier series, Fourier series. The basically is the Fourier series formula, and for this one only have sine term. This is like a Fourier sine series, right? you can either look up the Fourier sine series formula, which is somewhere in the chapter, or Fourier series should be chapter 19. If you are not familiar, you can look back to this chapter or look at my this semester video. I should have included all the last semester's video, but the problem with this video on campus is that the name is by date. So if you don't know which date I cover this, that would be a problem. So another option is in my YouTube channel. I have all this. I included the topic in the name of the video, so you can search search Fourier series, so you should get all the video that has Fourier series at the name of Fourier series in the file name. So that part you can kind of review the Fourier series, but let me show you the formula. Fourier series, where did we get the Fourier sine series? Fourier sine series, correct Fourier sine series is equation 19.11 or 1913. Yeah. Yeah, except that that series has from minus L to L, we have 0 to L. So basically, you can either look up a standard textbook, but you make sure you can apply to the same problem. So basically, this is a Fourier series f of x equals the sum over n. So if it is a Fourier sine series, you only have the sine terms, so your an sine. Let's just keep using this coefficient. Sometimes you get rid of the pi over L and then pick out what the domain is. Like the domain is 0 to pi or something like that. But our domain is 0 to L, right? So that's the Fourier expansion. So you want to find a sub n. So what you do is multiply by the same function. So fx sine x over L. And do an integration from 0 to L dx, right? And what you do is you substitute this into here, right? Now, when you substitute this into here, you need to change this, or you either change this or change that. Doesn't matter. Or you can say I multiply m, that is fine. So multiply m pi x. So you substitute this into here, then there would be no conflict, And then you have the base of n, and then sine n pi x over L, sine n pi m pi x over L dx. Okay, and now I claim that this is 0 for n not equals to m, right? That should be 0 for n not equals to m. To do that, to show that you use the product identity for sine function, sine A times sine B. Do you remember that formula? you remember? Okay, sine A, sine B, what is that? This should be something cosine A plus B, cosine A minus B, plus B minus. Let's figure out. Because that will give you cosine A, cosine B minus sine A, sine B, right? So that should be a minus sign. This should be a plus sign, right? Right? Yeah. I don't like to remember formula, but
And we'll get 2 sine effects.
yeah, you have yeah. But anyway, so you get this this two term. So you have a cosine of A. If this is A, this is B, then A plus B will be N plus M times X over L, right? So it will be cosine minus sine, and then plus cosine and minus N minus M. It doesn't matter because cosine is even, right? And then when you integrate that from 0 to L, all this will give you sine, right? Sine. And obviously, if the argument is not 0, then evaluate 0 and L will both give you 0. So it's because sine n integer times, I forgot the pi. Integer times pi will be 0. And so all the if so this is assuming n not equals L. So that would be 0 also, because after you do the integral is 0, because you get a sign out. But the only case is non-zero would be n equals to L. And you use the same thing when n equals to L. This term will be 0. This term will be just 1, right? Because n equals to L. Oh yeah, you mentioned that this divided by 2. Divided by 2. Yeah. This will be 1. So this term will give you 1/2, and you integrate over 0 to L. So equals to L over 2 for n equals to M. Okay. So A, so that combining that is A n delta n, right? Or up to take the summation A sub m. The A sub m is fx times sine m n pi x over L. Wait, I forgot this L over 2. L over 2. Divided by L over 2, just like what I did. Divided by L over 2. Okay, so I just apply that. I go up a little, I thought everyone remembered the previous things. I went a little quick when writing this L over 2. Basically, just the L over 2 factor that you need some figuring out, because you suppose that you remember, you just, to calculate the coefficient, you just multiply by the same function, right? Obviously, you should remember that. That part is easy to remember. Only the coefficient is something. Is that okay? Yeah. Yeah. Okay, so that's a Fourier series. Any more?